So what we're trying to do here is trying to figure out like what user can do if something like that is reported. You know, my test is running and it crashes with SIG-IoT. First of all, how do we know that tests are crashing with SIG-IoT? We have a great thing called MiniHUD, which can sometimes find out what's going on with the test, right? So we see, you know, process exit crashed with exit code, process crashed with exit code. And if we scroll through here, we have a lot of failures recently, but they should be, no, well, it's no longer the case. But luckily, I captured some of the regressions that we had yesterday in the issue. Here it is, right? So the issue is pretty old. It happened rarely, then it started to happen more frequently. I think it happened like 6 or 7 times yesterday. So I grabbed some of the actions here. Right, and if you click on the action, it's not very helpful, right? Like, you know, first of all, ensure that minimum NVIDIA driver version is such and such could not cause any tests to fail. Right, so what can we do about it? First of all, we need to find the pull request it was associated with. All right, we can do that by going into summary. Up. And GitHub is down. Right, we go into summary. And oh, it was a trunk. So if it is a trunk commit, we can just replace this one with hot.pytorch.org. And it should give us a nice view of the commit. Right, and what we can see in this view is for the build artifacts that crashed with SIG-IoT, we should have core dumps. Expand to see artifacts, and that's something that I hoped for. We have a lot of artifacts here, and we have a huge one which no. That's a sad regression. Oh, this is a core dump. So here we go. This is the core that we want to debug for the process that crashed. So how can we do it? We need to get an access to the same environment. Luckily, we're on a Linux system, so we can just grab a Docker image. So all we need to do is, so I have a pull request here that hopefully still running something. Right, and they should find any Linux build. I don't really need, just need a pending Linux runner, and that will do. Anything actually will do. Like all the CI machines have this setup SSH option, and that unfortunately limited to Meta employees, but we can figure out, like, it can be any Linux box. I'm just going to reuse the ones that we already have. Right, and go into SSH into it. So I'm on the box, but it is just a Linux box, right? I use this as an example because this is a Mac machine. I don't have a Linux machine at my disposal. But you can see it's running a wrong Docker image. So first of all, we need to find the right Docker image for the job. How do we find it? Again, we can see it from the logs, right? So if we go back to our HUD, right? So first of all, let me start copy link address. I should be able to download the core here, don't I? Should I do it here or should I do it in the container itself? Let's do it in the container. So first thing first, I need to find the job where it happened. Luckily, it should be at the very top of the queue, right? So this one failed with SIG-IoT, right? So if I click on this one, I should be able to actually see the job run. And there is a step called pull Docker image that gives me all the information about the Docker image that I need to pull, right? And here's a Docker image name, right? And all I'm doing here is pulling it. Oh, I already have it. That's great. I didn't expect it to be the case. Oh, so we are actually on the same Docker image for the Bazel builds as we are for this particular issue, but usually you would not be that lucky, so you need to download Docker image and exec into it, right? But I can reuse the same container. So just to give you an example, so one can always say something like docker run interactive terminal, right? And then I can do bash, and I have should have a new Docker container, right, where there's nothing running. And now I can repeat my, so let's do it in the new Docker container. Now I can repeat my curl command, right? Oops. Oh, because we are in the wrong location. I'm Jenkins, but my home folder is missing. No. Okay, now I can do it. So while it's downloading the core, what is a coredump file? So coredump file is just a status of the memory of the process at the time it was crashed, with all the threads that are associated with the process and all the registers associated with the process. So that should be, it is very extensive. Why it is so big? Because it allocates a lot of memory while we're running our tests. So apparently this test allocated like 4 gigs of memory and like initialize it with some data. And by the way, you don't need a GPU machine to reproduce what's going on because you're just loading more data into memory. So there's a couple of tools that one can use to, so let me get back. So there's a couple of tools that one can use to load debuggers. There is 2 major debuggers. One is a GNU debugger, which calls GDB, and another is debugger from a CLang toolkit called LLDB. Both of them are fine. LLDB was receiving much more attention recently and much more friendlier to newer C++ standards, but I don't think we will see some advanced C++ features. So let's see if we can just use a good old GDB. If not, we probably also need to download the exact binary that was running, but again, we're lucky because, so this is Linux Bionic CUDA 11.6. Linux Bionic GCC7 artifact. So this is the artifact that I need to have, right? Is that the config that it's failed? Yes, Linux Bionic CUDA 11.6. Right, so as cache stats, which is interesting but not what we need. What we need is this guy. Oops. So you might be wondering why this artifact is just 600 megabytes versus our like CUDA 11.6 wheels are about 1.5 gigabytes. The problem is that this artifact is not hermetic, and this is why we need a Docker container. So this artifact can only run within a particular container, right? So anyway, we can. So we have a core file. We can see if we can just.
I have a question.
Yeah.
So what is this artifact zip that you're just downloading?
Sure. So let's see what's inside. Oh, we don't have an unzip. That's a surprising state of the things. Apt-get install vim. So the Docker containers are designed for running CI. They do not have a lot of tooling that you would expect in a normal developer workstation. So we'll probably need to install a lot of things. So I'm using apt because it's an apt, like it's Ubuntu-based Docker image to install those things. And I wonder where zip would be. In an unzip? Yes. So this artifact should contain a wheel file and a binary and a C++ test, because this failure actually happened in C++ test, right? Unzip-t artifact zip. Right, so it have a wheel file and a bunch of tests. right? So that's kind of what happens as a result of the build. So when you build for CI/CD, it produces artifacts. And these artifacts can be downloaded to reproduce any problem, and you get byte by byte results from a builder. So if I have GDB, can I just load core? What do you think? So I can, but you know, results are not very interesting. So I know the command that was running. Actually, I was right. I was wrong. It was not running a C++ test. It was running Python test, right? But I don't know anything. You know, it's very kind of. Sorry, it's GTB. So I don't know anything about the threads. I don't know anything because I don't have any symbols, right? So the thing I can do is I know what it was building from. So the command was a Python build, so I can do this. But again, I would be in a sad situation because I need to install my libtorch to get the symbols from torch. So if I do that, right, so the life is a little bit better. We can load some symbols, but we see this warning, you know, I cannot load symbol blah, and all the torch symbols would be in this state. But at least we know that we're now in libc. We hit GI race, which is...
I'm going to ask a few more questions.
Sure.
Sorry to cut you off. So you loaded symbols from that one file. Is that always the file we should be loading symbols from?
No. So the, maybe I should return to the command. So what this command does, when you tell the debugger that this is my executable and this is my core dump, right? So like when we loaded the symbols, right, if you just run file on the core file, it will tell you a very interesting thing, right? So this is a core file for Linux x86, which is not surprising. That was generated from this command. So that was the executable. And that is the executable that I need to pass to debugger so it can start relocating information, symbolic information, right? The core dump does not contain, so core dump contain only modified dirty memory. So dirty memory is a memory that cannot be discarded from the virtual memory environment. So the way that modern executable is loaded, right? So if I like start conda bin Python, right? It doesn't actually load the entire executable in memory. It creates something called memory map, where it creates something called on-demand paging, where like you just load the pages that you need, but those pages are not saved in core dump because they already have a backend storage, namely file system, right? So this is why debugger needs to know the executable and shared libraries to be able. Have I installed LLDB? No, let me install LLDB, because like why I recommend people start using LLDB, because LLDB is default debugger that, like, again, it is more advanced, it is faster, and it is a default debugger that you have on your Mac machines, which is also a good thing, right? So you don't need to know like a different set of commands for GDB versus LLDB. But the syntax should be very simple, right? So I just did GDB, I do LLDB here, and it probably would work the same way. No? Nope, it didn't. No, go ahead.
Question. So I never use LLDB, but do they support also all the tooling that GPDB have to debug like Python applications? Because sometimes you want to go in between the Python land and the like C land to understand like what the setups and lines that run before.
So neither of the tools support it out of box, but both of them have an extension that support it. Right, so I don't think you can debug Python code in GDB from scratch, and I don't think you can debug Python code in LLDB, but yes, both of them have wrappers that allows you to do that.
Yeah, so there's an extension as there is for GDB, okay.
Yep. So I think with LLDB then I probably need to do something like that. And now we load in the core dump. Yes, so the syntax is slightly different. Right, and now I can have my backtrace, and let's say, you know, like here, but it's not again very useful backtrace, and but we also know that we started a lot of threads, right? Most of them doing nothing, but again, we still need to install PyTorch from our artifact, right? So let's do a like Why do we need to do it? Let me show you again. Like we load the debugger. You can do image info, image list. So what does it do? It gives you an information about shared libraries loaded at the address space. So this command works both for live debugging and so-called postmortem debugging. So postmortem debugging is what we're doing here when we're debugging the process that's no longer live on the system, right? And it shows you all the libraries that were loaded and whether those libraries have a symbol resolved for them. And you can see here that this one does not have anything at the moment. So we cannot extract symbolic information because this one, for example, does not exist, right? If we are to have,
Sorry, how do you know it doesn't exist?
So it's not very obvious, but there is a third column here saying that symbols was resolved or not. Or maybe I can type image info. So we need to install it. Like we can try to figure out the exact command, but let's like go ahead with like installing the artifact and right. So we do zip -t. Oh, not -t, -x. I don't care that the thing is valid. I just care that the thing works, right? And then I need to install it in the same location. So I'm going to run pip install. Do I need to run it as a sudo? We'll find out. I have no idea.
I'm sorry, Nikita. May
Yeah.
I interject?
Sure.
I think the text is very small. It's kind of hard to see it. Can you please just make it like
Sure.
zoom it in?
Is that any better?
Thank you so much. Yep.
Yep, cool. Okay, thank you. Yeah. So now again, we don't have anything here, right? So how we can anything here? Very simple. We do pip install. First of all, let's make sure that our pip is the pip that we expect to run. Yes, it is. And Python version is indeed Python 3.10. So we do pip install our build artifact. And now we actually replicated like what was running. We can just easily go ahead and run some tests if we choose to. Right, let's just make sure that, you know, Python is now importable. Sorry, PyTorch. Yeah.
Is the wheel that you kept installed, is that the only wheel that's part of the artifacts folder, or are there multiple wheels?
There is one wheel in artifact folder, but there are other files, right? So we do not package binary tests, and I don't know if we need to or not, right? So that's the only wheel, but there is a bunch of files in the build folder. There is like a bin where all the binary like tests, what is it called? C++ Google tests are stored, right? But in this case, our core dump is a Python core dump, so we don't really need it. But yeah, that's all. And again, this is all just a build artifact. So this is something that our build stage produces and packages. Right, so again, like Python, import torch version. Is whatever the hash sums that we build it out. What is it called? Like, I don't know, x equals torch round 5.5. Alright, and let's do the matrix decomposition. That's my favorite test for especially on ARM machines, because it needs to make sure that you build not with only OpenBLAS but LAPACK. So we can do x t like that, and like that. And yes, we have like upper diagonal, lower diagonal, and eigenvalues. Great. Anyway, so now back to our story with backtraces. And if you remember, like the last time we've seen backtrace, it wasn't very informative. We only see that, you know, we crashed with an handled exception. Where this exception is coming from, we had no idea. Let's see if having more symbols will help us in any way. So BT is a short for backtrace. And now the backtrace is a bit more interesting, not that much. Oh, we are throwing it from Kineto library. That's an interesting change. But maybe that's a wrong signal. Or maybe we had more than one crash. I'm trying to understand, like, if we have more than one core here. Core? And that's just only one. Why is it a Kineto crash? Test JIT code diffuser, no. And that's what we see in the command, right? We was running test JIT code diffuser, so that's the right backtrace. But let's see what's going on here. So we throw bat function call from Kineto config. Interesting. So bat function call is usually thrown when you call std functional. We don't have any symbolic information. I thought we used to be able to build with -g, but we don't.
Nikita, I'm gonna ask you a few more questions real quick.
Sure.
So I see you using a lot of commands. I don't know what most of them mean.
Okay.
Maybe kind of like walk us through what exactly is going on over here.
Indeed. This is weird. I didn't expect that. So yeah, the most important command is backtrace, right? Backtrace gives you a backtrace, which is the stack of commands, the stack of function calls that led you to this crash. Another interesting one is thread info, right? That tells you that
A stack trace?
Yes. So it is. You can think about it as a stack trace. Yes. So you see, like. Is there a thread 0? Maybe there is a thread 0. But yeah, it's because it says that the stop reason is sig abort on this thread. Right, so we raise signal number 2, which is abort with verbose terminate handler. Terminate, we call a regular throw, so we raise an exception. We raise an exception with std bat function. Std bat function, yeah.
Could it be like just two threads, crash and separate as one, crash to sig abort, and crash to sig
Thread list backtrace. Oh, we can do thread. So this will dump a lot of information. It can be. Like, let's see what's going on. So this is all our threads and all its backtraces. So we had in total 36 threads because we usually run in our CI in 36 core system. So let's see what's going on. So the thread number 1, which is a default one. Yeah, go ahead.
Sorry, I just have a relevant question. So, do we compile things with some level of optimization?
Yes.
That can, for
Yes.
example, inline functions or something
Definitely.
like this?
Yes. But we should.
Should we make maybe some of the function calls be opaque in our backtrace?
So you say like whether inline functions can disappear in the backtrace? Yes.
They do disappear, right?
They can. So it is a tricky thing. If you have a symbolic information, you can emit a debug information that this part of the code belongs to inlined function, right? So even if function is inlined, there is something called tail recursion. So tail recursion is a thing like that, right? So if you have a function foo that takes an argument x, right, and it right, and you have a function bar, right, that bar, sorry, in text that does something like right, so suppose we allow something as stupid as that. right? So this weird code says, you know, I'm going to take a lowest bit of the argument x, make it a pointer, try to read from the address either 0 or 1, and then compare it to 0. So this guarantees to crash, right? Let's actually compile this thing, right? And yes, it needs to be the other way around. I still don't know how to compile, how to write code. In bar, so we're doing this, int x, bar, full. What can go wrong here? Oh, because we're saying that this is a C++. Let's say that, oh, wrong parentheses. Yeah, wrong parentheses as well. Oh, my main function. It is an error. That's an interesting. Sure. Right, so this will crash. We have another core file, which is much smaller, right? And we can actually now load it into our debugger. So let's do and see where we will crash. So you see, we see the both function calls because we compile without optimizations. Let's do O3. Right, and let's just run it with debugger. I don't want to generate any more core dumps. What? Oh. Core dumped. Which one is ours? Probably 95 now. Oh, because I didn't launch the container. So this is an interesting thing. So this error is a very fun one. If you ever encounter it while you are in the container, please remember that debugging live processes is a privileged operation, and most of the containers are launched without this permission. When we launch the container in CI/CD, they are usually launched with capability systrace or something like that, right? So this is why, and it's very hard to interpret, right? Process launch failed, packet returns 0, and error 8, but error 8 is actually, if I remember correctly, is SIGFP? No, it doesn't sound right. Yeah, can't execute. Exec. So exec usually means that like you can't launch the process with the ptrace permissions in this case. It should have returned eperm, but like if you try to launch process as a debugger without having the debug permissions, you will see something like that. Anyway, but we have our core dump, so let's load core dump, and we will see that oops.
I need to ask a stupid question.
Yeah, sure. Yeah.
What is a.out, and how did you get a.out?
Oh, because when you compile something with compiler, by default, on almost all Unixes, your executable name is a.out. Right? I can specify gcc-o something foo cpp, right? And then my executable, lowercase o. Uppercase o is optimization level, right? And then my executable will be foo, right? But by default, if I don't specify anything, it's a.out. So anyway, what I wanted to show is that, the backtrace is pretty boring now, right? Because compiler is smart, it inlined all the functions, right? As I think John mentioned, and we see that, we crashed in the main function, which is not very useful. What we can do, even if you compile with optimizations, right? So let's delete core dump. What is that? not the ones that we care about, this one, right? So what we can do is we can do this, and I thought we compile it in CI with -g, but maybe we don't. So if we compile with -g and we run it, right, our backtrace will be much more interesting. Right, we actually see that, we crashed on line 2 of our example application, right, and I can do up, and I can even do this one, right, and like I have a nice backtrace. I know that, if I go down, I don't know how to do this, right, but if I know go down, like this is where I am, I have my variable x, and I can even print its value. So even though the function is inline, if you compile with debug information, debugger embeds specific information saying, that this assembly code corresponds to this line in source, and this actually corresponds to an inline frame. But if you compile without debug information, then you only see the function names which are public, right? So yes, your backtraces will be, but the thing is, if you just look at the disassembly, right, then there's no function calls, and the worst thing is, like, even if there were function calls, right, if I call this both function global and prohibit any inlining, I wouldn't see it in the backtrace because something called tail recursion happens, right? So when I call this function bar, I don't need to do anything containing information about function foo at this point. So execution of function foo is finished, and it just passes execution to function bar. So actually, this is like, it's a very common compiler optimization. So this does look like a function call, right? So there is a call instruction, jump instruction, call instruction puts return address on the stack. So when you have something like that, compilers very often get rid of the call instructions and jumps into the next function. That's a standard optimization. You don't need to put unnecessary things on stack, but then it makes it debugging harder. Does it answer the question? But anyway, let's get back to our original. So I think, I don't remember who asked the question, like, can we have problems or like exceptions in other threads? Yes, we can. When we load coredump, we by default select, I think, the first one, the first thread.
Yeah, so Nikita, sorry, I was asking because basically the test crash showed SIG IoT, and I just read up that SIG IoT could happen when basically there is SIG abort somewhere else, and it just triggers all other threads to SIG IoT.
Yes, yes, correct. Yes, so SIG IoT, yeah, go ahead.
Yeah, so basically we're probably looking at SIG IoT in one thread and SIG abort in another thread.
Oh, yeah, so we might even, so let's see, right? So this is what I did. I dumped all the threads, but we can probably see that neither of them, and we have 36, but all of them are OpenMP created threads, right? Or OpenBLAS, and they're probably not doing anything. Yeah, they're all waiting for some work, so there was no parallel work scheduled anywhere at this moment except for our thread 1, right? But yeah, it crashed with SIG abort, but it got reported back as SIG IoT. I don't know why it happened like that, but looks like this is a crash, so we... Oh, interesting. So we tried to update Kineta config. So usually what it happens, if you have a C++ Lambda or a function wrapper and you don't initialize it to anything, then it will crash exactly like that. So to give an example, let's call bar CPP, right? Right, int main. Right, let's return 0, and suppose I have std. And I do this. And so I created a function, I created a class that should contain a function, but I didn't initialize it to anything. I tried to call it, and it should do exactly like that. Let's see. yes, bad function call, and if we load the core, again a out, 4307 probably, right? So we see a very similar backtrace. Throwback function call, std throw, terminate, unnamed symbol, abort grace 2, right? And maybe actually if we look at the backtrace or some of the outputs, we can find it somewhere in the code. So do you guys agree that this looks like a very similar backtraces? So very likely somewhere in Kineto. Right. Oh, I didn't.
What is the fg command here?
Foreground. So I can put something to the background, I can put something to foreground. If I press Ctrl Z, right, I put something in the background, I can see jobs, and I have my job stopped, and I can do foreground, and then I control the job again. You can do it with text editor as well, right? I can open Vim, I can press Ctrl Z, now I have two jobs, and I can do foreground 1, and I'm in debugger. I can do Ctrl Z, jobs, foreground 2, and I'm back in my Vim. Right. So
Control Z.
yes, Control Z sends process to the background. It sends you. I'm trying to remember. Does it send sig hub? I don't remember which signal it sends. 19 probably, sig stop. And then foreground it sends signal 18, sig cont. Anyway, so I don't care about this guy. So we have this one. This is my dummy example. It's not a real. Oh no, it is from Kineto, right? So let's post it in the issue. Or did I close? No, I didn't. My browser is super slow. I will post it later, right? But we can probably look into where it is in PyTorch codebase. Kineto config. Update config thread. Right, so we do wait a second, I'm trying to, so we create a thread that calls a function in config. Oh, this is a config loader. It creates a config object in config loader, right? And what is the config object? And we have some factory map, and we have some config factories. Not config factory, so config. I guess we do this, and we find config factory or something like that. So that's probably what's causing SIG-IOTs. So we should reach out to Kineto guys and ask them to debug, or we can try to run this test in a loop and try to find out, or just do the code analysis. Or another interesting thing. So this is a kind of problem that should have been caught by thread sanitizer. So if we have a thread sanitizer and we run this test, we should be able to see some thread sanitizer violation. I think what we're doing here, though it feels very weird, is that we are making some function calls before the initialization started. But yeah, this finishes it, I think.